Hello, we have here a block being put by a 40 newtons force which is inclined at an angle of 30 degrees to the horizontal. So as the block is being dragged along, it experiences a constant frictional force of 20 newtons. At the same time, there's still the weight of the block, 30 newtons, and there's a normal contact force of 10 newtons. So the question is, 2 meters down the road, what will be the KE of the block? Or maybe the gain in KE of the block. So you have learned the concept of work done by forces. So what we have to do is to just figure out the work done by all these forces, and that will be the gain in KE of the block. So let's start with the 10 newtons and the 30 newtons. Now these two forces are vertical, but the displacement of the block is horizontal. So these two forces couldn't have done any work on the block because they are perpendicular in direction to the displacement. So the 10 newtons and the 30 newtons forces did zero work. What about the frictional force? It's acting leftward, but the displacement is rightward. So the force and the displacement are exactly opposite in direction. In such scenarios, we know that the work done is negative. So 20 newtons times a negative 2 gives you negative 40 joules. Lastly, the 40 newtons force. This force is neither horizontal nor vertical, but our displacement is horizontal. So the smart thing to do is to resolve it into its horizontal and vertical components. So notice the vertical component, just like the 10 and the 30 newtons forces, is going to do zero work. So all we have to take care of is the 40 cos 30, the horizontal component. So the work done by the 40 newtons force is just 40 cos 30 degrees times 2, which will give you 69 joules. So overall, the net work done is a positive 29 joules. This comes from the positive 69 joules of work done by the 40 newton force and the negative 40 joules of work done by the frictional force. So that's how you apply the work energy theorem. That's all. Ta-ta!